Okay, so I lied. We'll do two videos. Why? Eh, because I realized that maybe factorization was still something we were having issues with. So, factorization for us is nothing more than breaking down the parts the parts of an equation or the parts of a number. I'm going to break this pen. So, product. What does product mean? And a product results from a factor times a factor equals a product. Yes, it's in the fridge. So a factor times a factor equals a product. So when we are saying that we are finding the factors, we are finding what times what equals this number. Okay? So let's go on ahead and clear all of that. So 60, there's two different ways we've taught this. One is with the branches and the tree method. So with 60, we can go any number of ways. Let's say 4 and 15. 4 times 15 does equal 60, so we're good to go. Are these prime factors? They are not, because we can still break them apart. So then we look at the 4. Can we do the 4? The 4 breaks up to a 2 and a 2. Those are prime factors, so let's go on ahead and square them. And squared. And then 15. 15 gives us a 3 and a 5. Okay, so now the prime factorization for 60, according to this, is 2 times 2 times 3 times 5. 2 times 2 times 3 times 5. Now remember, I always want to see this in exponential form. So with exponential form, let me change colors. Let me get the pencil back. There we go. This pen is so sensitive. Okay, so exponential form. My base is a 2. I have 1, 2 2's, so my exponent will be a 2. Then I'm multiplying by 3, and I'm multiplying by 5. And now I only have one of them, so I don't need to write an exponent there. Now, the other option, and as you all know, my preferred method, is the ladder diagram. And the ladder diagram reminds me a whole lot more of an upside down division symbol. So with the ladder diagram, you always want to start with your lowest prime factor and work your way down. So 2 goes into 60. That leaves 30. Well, we can cut that in half again because it's an even number. So 2, that gives us 15. We no longer have an even number, so we got to go on ahead and find another one. 3. 3 goes into it. That gives us a 5. Pull the 5 out. That leaves us with a 1. And as you remember from class, because it's 1, we are done. And what do we have? We are right back where we started on the other side. We have 1, 2 2's, 1 3, and 1 5. So either way you do it, the prime factorization is 2 squared times 3 times 5. Now, I think some of you are really upset when all the Dr. Berger's videos start with even numbers because even numbers are so easy, right? They just straight up are easy because they start with what? 2 every time. So let's do a 79 instead. All right. No, I don't want the eraser. I want the pen. I want it that color. Okay. So this will be a new one for me because I honestly don't know this off the top of my head. I know that a 2 won't go into it, so let me see if a 3 will. 3, 2, 6, 1, bring it down. That's a 9. That's a 6. Did I pick a prime number to show you? 3, 4. It's not a 5, not a 6, not a 7, not a 8, not a 9, not a 10, not an 11. I did. I picked a prime number for you. And that, my friends, is the reason Dr. Berger doesn't do this with random numbers half thinking about stuff. So instead of 79, hold the phones. Abigail, I need a number between 1 and 100 that's odd and has more than two factors. Yeah, and I want it to be odd. 87. Okay, so let's try 87. We're going to play with it my way because my way is easier whenever we're doing something simple. 2 does not go into this. Does 3 go into this? 3 goes into 8 two times. That gives us a 6. Wow, working upside down is difficult. Oh, that's not what I wanted to do. What'd she say? 87? All right, so let's work over here. 3 divided by 87 goes in twice. That's a 6. Bring it down. That's a 2. That's a 7. Oh, look, 9. 29, 27, 0. All right, beautiful. So 3 goes into that. That gives us 29. All right, so what goes into 29? Let's come over here. We'll actually use the eraser this time. Get back to the pen. 29. Will 3 go into the 29? No, no. And then that'd be a 9. 9 times 3 is 27. So that doesn't work. 4 no, 5 no, 6 no, 7 no, 8 no, 9 no, 10 no, 11 no. Huh. 29 yes. 1 and done. So I gave us a prime number to start with. My daughter gave us the next closest thing to a prime number because there's only 4 factors in this: 1, 87, 3, and 29. So, to the student who told me Dr. Berger's numbers are always way too easy, yeah, you're right, because I just proved how difficult this can be. But if you stick to it and you start with the foundation, start with your lowest prime numbers and slowly work your way up, you will get there and you will figure out that sometimes there's only 2 that you're going to find. So the factorization of the number 20 or 87 is 3 times 29. Again, tutoring every morning, 7:15 or sorry, 7:30 to 8:15. Let me know the day before, that way we can make sure there's a pass in the box for you. Hope to see you there. Bye.